may be wondering why I'm on this kayak. Quite frankly, it has nothing to do with today's topic. I just like kayaking. Hopefully I don't get lost at Sue. In life, some things are given and some things are taken. Just like electrons in a redox reaction.
There are many real-life applications to redox reactions.
Yeah. One real-life application to redox reactions are galvanic cells, or batteries, like the one powering this phone.
Welcome to our wonderful world of chemistry. Today we'll be talking about redox reactions, also known as reduction-oxidation reactions. This means that the substances within the reaction will be experiencing a change in oxidation states. So you may be wondering, what is an oxidation state? First, you have to understand what reduction and what oxidation is. Oxidation is the loss of electrons, which causes an increase in the oxidation state. For example, neutral calcium is oxidized and then becomes Ca2+ with 2 electrons. On the other hand, we have reduction, which is the gain of electrons, which causes a decrease in the oxidation state. An example of this is F- gaining an electron and changing into the atom of fluorine. So now we can revisit our first question of what is an oxidation state? The oxidation number / oxidation state is the number written as an exponent. So in our first example with calcium, calcium changes from having an oxidation state of 0 to an oxidation state of 2+. In the case of fluorine, fluorine changes from having an oxidation state of 1- to 0. The oxidation and reduction of different substances can be written as a half reaction, seen below, with our calcium half reaction and our fluorine half reaction. There are also things called oxidizers and reducers. Oxidizers cause other substances to oxidize, thus oxidizers become reduced. On the other hand, reducers cause other substances to reduce and become oxidized themselves. So when two half reactions are combined, such as calcium and fluorine, as we previously saw, the electrons must be balanced to form a redox reaction. The two balanced half reactions are calcium over here and fluorine over here. When these two half reactions are combined, there are some atoms or molecules that are neither oxidized nor reduced but are spectator ions. The reaction that we've previously shown above with calcium and fluorine, these do not contain any spectator ions, but a lot of real-world examples contain spectator ions. Here's how you combine the example above. You would take the two balanced half reactions and combine them so that their electrons are equally on both sides. You have to consider which is becoming oxidized and which is becoming reduced, and combine them accordingly. One example of a redox reaction is a halogen displacement reaction, where you have a lone halogen displacing a halogen in a compound. The lone halogen is oxidized in this case, and the halogen in the compound is reduced because it is going from a charge to having no charge, and the lone halogen is oxidized because it's going from having no charge to having a charge within a compound.
Another type of redox reaction is a hydrogen displacement reaction, where hydrogen atoms in water are reduced to H2 gas by alkali metals and calcium, strontium, and barium. Another type of redox reaction is a combustion reaction, where a substance burns in the presence of O2 to produce an oxide. So oxygen goes from O2 uncharged and becomes reduced to O2-. Another type of redox reaction is a disproportionation reaction, when an element in an oxidation state simultaneously undergoes both reduction and oxidation, such as when copper 1 chloride goes to solid copper and copper 2 chloride. It is both oxidized and reduced.
Modern-day batteries can also be known as galvanic cells. Galvanic cells operate based on redox reactions. To show how galvanic cells operate, there is a shorthand notation used that simplifies all of the elements and their ions. This is the shorthand notation for zinc and copper. As you can see, the metals in their solid states go on the outside and their ions go on the insides, separated by the double line. A real-life application of a redox reaction is in a smoke bomb. Here is a chemical reaction for a simple smoke bomb. As you can see, the potassium nitrate reacts with sugar to produce carbon dioxide, potassium carbonate, water, and nitrogen gas. In this reaction, the nitrogen is reduced, which means that it gains electrons, while the carbon is oxidized, which means that it loses electrons. For a simple smoke bomb, you need brown sugar. You also need potassium nitrate, which is found in fertilizers. I'm grinding potassium nitrate so that it reacts better with the sugar. You need alcohol. You need baking soda. You also need a fuse, tape, and matches.
My name is Don Showalter, and I love smoke bombs. Let's see how much this bomb can produce.
I'm going to light it. It's going. I'll light it again.
This lighting is good now. It smells like burnt paper towel.
Good observation, Don. Yeah, that is smoking. That is smoking. My God, that's...
Wait,
Oh my gosh.
should I not be close to you?
That is a smoke bomb.
Hello.
Oh my God. CO2 gas and N2 gas are normally clear, but when combined with potassium carbonate and impurities from the sugar, it turns the smoke white. Just how you saw.
No, Satan. Satan is a master of lies.
Calcium, strontium, and barium. I'm getting pantsed by just a pinch of.
Alex, push your back out.
Why? I'm lost at Sue. Oh dear.